So let us discuss the last question from day 6, that is the flattening link. So your last question है day 6 का, let's do it. We are given the linked list of size n where every node represent a sub list and contains two pointers. Okay, तो हमें एक linked list दी हुई है n size की where every node represent a sub list, at which every node represent a sub list. There are two pointers, the next pointer pointing to the next node and a bottom pointer pointing to a linked list where this node is the head. Okay, okay. So we are given a linked list in which every node is the head of this sublinked list that is represented by the bottom. That is the bottom linked list that is towards the bottom. Okay. Each of the sublist is in sort order. Okay. Each of the sublist that is approaching bottom is sorted, and every node in this linked list also it is sorted. Flatten the linked list such that all the nodes appear in the single level while maintaining the sorted. The flattening list will be represented using the bottom pointer instead of the next. Okay, so we have to make a single sorted linked list from these sublinked lists such that the resultant linked list, that is this single linked list, is also okay. So basically what we have to do, we have to merge these linked lists, this one, this one, this one, this one, and we have to merge it in sorted manner. So how are we going to approach this question? This question looks very interesting. So let's see how will we solve this question. So what is the given scenario in this question? We are given the sorted linked list. So this is the main linked list. In this main linked list, we have attached at every node we have attached a sublist. This is a sublist. At every node act as a head of the sublist that is pointing to downwards. Okay. So this is the scenario, and we have to merge these sublists, all the sublists, sublist 1, 2, 3, 4, to get an single linked list in which all the nodes, all the elements of the sub linked list are present and they are all in the sort. So how will we solve this question? We have solved a question named merge to sorted arrays. Okay, we have solved previously this question. Okay, we have previously solved this question. So these are two sorted arrays. So what we have to do, we have to recursively merge these sorted arrays, and at the end we have to return the answer. So how will we do it? At the starting, our head will be pointing to this. So let me clear this. Clear this. One sec. Okay. So what we have to do, we have to recursively merge these sorted arrays till we get and single linked list. Okay, to get in single. So this is the array given to us. So sorry, sir. So this is the linked list given to us. We have to at first our head, the total head is pointing to this. Okay, what we'll do, we'll maintain a pointer to this one, that is head 2. We will traverse these two linked lists and merge them in a sorted manner. So what will be the output? 5, 7, 8, okay, 8, 10, 20, 20, and 30. This will be the output when we merge these two sorted arrays. These two, L1 and L2. If we merge them and we link it with this, the next. This will be the output when we merge two adjacent sorted arrays recursively. Same we'll do it with these two. These two. Same we'll do it for these two. This will merge in single linked list. So what will get the output? 5, 7, and whatever will be the output. Now we'll merge these two in a single linked list. Now we'll again do for these two. Until we have pairs, we'll merge them. And we got uh, when we got only a single linked list, we'll return because we have got a single linked list that is sorted. So this is the approach how will we solve this question, and it would be more crystal clear when we look at the code for this. So what is the algorithm or the intuition? We'll recursively solve, we'll recursively merge two adjacent sorted arrays. Okay, we'll merge them until we are remain with single linked list. Okay, until we are remain with single. So let me show you the code for this. Now we'll discuss the code for the approach. We have a function named merge sorted that returns the node pointer. It have one parameter that is the root. If that is the condition, the base case, if there is only one sublist present in the whole linked list, we'll return it. Because there we have to just return a singly sorted linked list. If that is present, what else we have to do in the link? जब तो मारेंगे नहीं इसमें तो वो ही return कर देंगे. Okay. Else, if we have more than one sublist, what we have to do, we'll store the head of the sublist 1 in T1 and the head of sublist 2 into T2. And we'll store the next to the next pointer, and that is the pointer to the next sublist in the in the pointer name Podosi. Okay, and we'll maintain two pointers head and temp that will be used. That head will be pointing to the head of merged list. If we merge two adjacent lists, this head will be pointing to the head of that merged list, and temp will be used to traverse. Temp is used to traverse the linked list. Okay, merged linked list. Okay. So how temp will be used, we'll discuss. So while T1, that is the pointer pointing to the head of linked list, sublist 1, if it become equals to null, or it will be pointing to null, or t2 will be pointing to null, till then we will run this while loop. And in this we have specified the condition, if condition, if the value pointed by t1 is less than t2, because we have to merge them sortedly, the same condition we have applied, which we have discussed in merge to sorted arrays. We'll create a new, if the head is null, if the head is null, we'll make the head points to the newly formed node that has the smaller value between the t1 dot data and t2 dot data, and temp will be pointing to head. Else we'll create a new node, and temp of bottom will be linked with the new node, and temp will become the new node. And at every point, if this condition satisfies, T1 will be pointing to the next node in the bottom list, okay, bottom sublist. Else, if this condition, the same conditions are there in if and else, but they are both for different sublist. This is for sublist 2, this is for sublist 1. Okay, so these are the conditions. We'll merge we'll merge the sublist 1 and 2, and if there are remaining nodes in the sublist 1, we'll dump in the merged list, and same for the sublist 2, we'll merge them in the merge linked list, that the sorted merge list. And what we'll do, we'll make the head of next point to Padosi, because the Padosi is pointing to the head of the sublist 3. If we have merged sublist 1 and 2, that will be pointing to this sublist 3. And if this sublist 3 is null, what we're gonna do, we're gonna end this. Okay, we're gonna end this. So it is a recursive function. So our head of next will be pointing to Kurusi, and we'll return the merge sorted, and in this we have passed the parameter as head. So what we are doing, we are merging two adjacent linked lists and passing the head of the merged linked list to recursively to this function, and this function will at the end will give us the output as the single sorted merged linked list. Okay, so this is the approach we're gonna use to solve this question. If you have any doubt, please feel free to ask. So I just forgot one thing. So this flatten function is the main function that will be given in the question. That if the root equals to null, we have received root as the parameter, and we have applied different checks here. If root equals to null, we have returned null. If root of next equals to null, we have returned root. And if these conditions do not satisfy, we have then passed our root to the merge sorted. And at the end, we have found the answer as one single sorted linked list. Will return the head to 10. Okay, so this is the approach. Okay.